For question number 11 on page 423, it says the limit as theta goes to 0, sine 3 theta over sine 4 theta. Now, you could maybe just rationalize this geometrically by comparing the two angles together, because geometrically the sine values relate to the angles. But we can also do this using an identity and using some algebra. So here we're going to first of all use this identity, sine alpha plus beta, to generate a sine 3 theta and a sine theta from the sine 4 theta. So applying this identity, I get sine 3 theta cos theta in the denominator plus sine theta cos 3 theta in the denominator. That's what I've written in red. And then I want to try to generate some ratios that I can work with. That plus is a problem in the denominator, so I'm just going to flip it and find the limit of the reciprocal value and then flip it back to find the limit. So flipping it, I can pair up the sine 3 theta over sine 3 theta. Okay, so this can be paired. And then we have the leftover cos 3 theta. And then I have this sine theta over sine 3 theta. Okay, that can be paired. And we have leftover cos 3 theta. When we apply the limit, sine 3 theta over sine 3 theta goes to 1. Cos 3 theta becomes cos 0, which is 1. Sine theta over sine 3 theta is just going to be 1 over 3. And then we can do cos 3 theta becomes cos 0, which is 1. When we add that all up, it's 4 over 3. And then we can work out that the reciprocal is going to be 3 over 4. For number 15, what we can do is we can generate a theta squared in the denominator by multiplying the top and bottom by theta. And I'm going to end up with sine theta squared over sine theta squared and an extra theta on top. So we let that theta go to 0, we get 0. Sine theta squared over theta squared is equal to 1. So the limit there is going to be 0. For question number 21, we're going to use some log properties. So firstly, we can only use logs with times and divides. So we're going to factor the extra y out. So we get ln y times y plus 2. We can use log properties to separate the times in here. The times in here becomes plus of the logs. And we're going to end up with ln y over ln y, which is 1. Ln y plus 2 over ln y. When we apply the limit, we get ln of 2 and ln of 0 in the denominator, which is from the right-hand side becomes negative infinity. Ln 2 divided by negative infinity is 0. So we get a limit equal to 1.